Hello friends, welcome to my YouTube channel Easy Mathematics. This video is on special request of Chandu Sen, who wanted to solve one linear recurrence relation by generating function method, and the question is this one. Here it is an minus 5 an minus 1 plus 6 an is equals to 2 to the power n plus n, where n is greater or equals to 2, and it is given that a0 is equals to 1 and a1 is equals to 1. So if you want to solve it, then initially we know that gx is equals to summation of n is equals to 0 to infinity an x to the power n. Now the given recurrence relation is this one, which we can mark as number 1. Now multiply the recurrence relation 1 by x to the power n, and summing from n is equals to 2 to infinity, we have this one. Here we take it x to the power n, we multiply by x to the power n because we want to need this type of function, and we summing up from 2 to infinity because it is given that n is greater or equals to 2. Now after this summing up, we will find out, like here this is summation n from 2 to infinity an x to the power n, because here it is the an given. Now it is the minus of 5, then summation of n from n is equals to 2 to infinity an minus 1 x to the power n. From here it is this one. Now 2 to the power n for 2 to the power n x to the power n, summation from n from 2 to infinity, and likewise for n it is n into x to the power of n, then summation of 2 to infinity. Now as it is given from n is equals to 2 to infinity, we should convert it to the n from 0 to infinity. But if we write so, then we have written two terms extra. One is when n is equals to 0, that is a0, and another one is when n is equals to 1, that is a1 into x. So we have to subtract these two. Now it is the next one, it is the n from 2 to infinity, this one for, we should write it from n from 1 to infinity because it is given that a n minus 1 from. So accordingly one extra term we have written, so that is a0, and which we should subtract. Next it is the 6x square of this one. Here no term will be extra, but as n from 2 to infinity is here, that's why we should take x square common. Similarly here from also we take x common, so that it becomes x to the power n minus 1. So now that one is equals to, here again this one is from 2 to infinity, so we should make it from 0 to infinity, and for that reason we write two terms extra, that is for n is equals to 0 and another one for n is equals to 1, so that we subtract accordingly. And from this term we should write it from n is equals to 1 to infinity, and accordingly we should write here, and one x should be taken out, so that this one is our, so after summation we will get this one. Now we just write down, instead of summation of n from 0 to infinity an x to the power n, it is gx. So gx minus 1 minus x, because a0 is equals to 1 and a1 is also 1, so that this one now minus 5x, it is gx minus of 1 because a0 is 1, then 6x squared and gx, then this one is equals to, we should write here this one from generating function table, which is you will find out in lecture number 13, where you will find out the generating function method. One table is given there. If your an is 2 to the power n and this one is your given series, then that we can write as 1 minus 2x whole to the power minus 1, then minus of 1 and minus of 2x. Then plus of x remains outside, and instead of this one it should be 1 minus x to the power minus of 2, and it is minus 1. After that if we simplify, then we will find out, look, then we will find out it is all gx had been taken in one side, so it is 1 minus 5x plus of 6x square gx, then minus of here from it is minus 1, then minus x, then minus of 5 plus of 5x. So it is completed, and from here it is, we should write of 1 upon 1 minus 2x, then plus of, from here it is x divided by 1 minus x its whole square, then it is minus 1 minus 2x, and from here it is minus x. So finally if we simplify this one, then we will find out gx is equals to this one. Just have a look how to solve. All the steps are done here. So just a simplification. We take the factorization from here. Then we should take it in this side and take the LCM for the entire thing and simplify. So finally we will get gx is equals to 1 minus 8x plus 27x square minus 35x cube plus 14x to the power 4 whole divided by 1 minus x its whole square, 1 minus 2x its whole square, 1 minus 3x. So now this function 1 minus 8x plus 27x square minus 35x cube plus 17x to the power 4 whole divided by should be splitted into this 5 factors. A by 1 minus x square plus b by 1 minus x plus c by 1 minus 2x its whole square plus d by 1 minus 2x plus e by 1 minus 3x. Now from here we are supposed to find out the value of a, b, c, d and e. So now how to find it out? Though this part is not necessary for this problem, but still I am giving you the solution how to find out a, b, c, d and e. After that I come back to the question again. So now if we take the LCM for the entire this thing, then we will find out this part. So here in the LCM, whatever we will find out as a factor, left hand side and right hand side both the factors are there, so that this becomes cancel out. Hence we will find out this part is equals to here. Now if this one is said to be the equation number 2, then in this equation if we put x is equals to 1, then we will find out that except this term all the terms are 0, because 1 minus x such factor is there. When x is equals to 1, then which terms belongs to 1 minus x, this factor all are vanishes, except that this term, the first term, all have contains this 1 minus x. So if we substitute x is equals to 1, then we will find out from here a is equals to 1 by 2. Similarly, when we substitute x is equals to 1 by 2, we will find out the value for c is equals to minus 2. Then when x is equals to 1 by 3, then we will find out the value for e, which is 17 by 4. Now when x is equals to 0 we substitute, then we will find out from the equation number 2 that b plus d is equals to minus 7 by 4. Because we know the value of a, c and e already, we should substitute these values in this equation. So we will get another equation, let it be 3, in terms of b and d. And similarly, if we substitute x is equals to minus of 1, then we will get one more equation in terms of b and d, which is 36b plus 24d is equals to minus of 27. We should term this one as equation number 4. Now if we solve this equation number 3 and 4, then we will find out the value of b and d. So while we are solving these two equations, so this one, from this equation if we multiply by 24, then it becomes 24b plus 24d minus of 42. And in this equation we multiply by minus 1, so that we will get minus of 36b minus of 24d is equals to plus of 27. If we solve, then we will find out b is equals to 5 upon 4. Using this value of b, if we substitute in the equation number 3, then we will get d is equals to minus 3. Hence, if we substitute all those values of a, b, c, d and e, then we will find out gx is equals to this one. So now by substituting all those values, we will find out gx is this one, and now here we are in the situation to convert it to the generating function. So gx means we know it is summation of n from 0 to infinity a n x to the power n, 1 upon 2 1 by x, 1 upon 1 minus x its whole square. That one can be written in this way. You will find out this one in the table given in the lecture number 13 for the generating function method in the discrete mathematics part. Now for this term we will find out this one, this term we will find out this term, and for this one we will find out this, and for this final one we will find out this one. So after that we just take the xn common from all those and we write the entire remaining portion here. So after simplification we will find out that an, if we compare on both sides, then we will find out an is equals to this one. Where n should be greater or equals to 0. And this is the solution of the recurrence relation. Hope you will understand, and if any such questions you will find out, then try to solve by yourself with very careful manner. I hope you can able to solve all the questions regarding this topic. Thank you.